Mrs. Malti Goel, and this was a very comprehensive introduction to this subject of concentrated solar power. This is a subject which has been under debate for not years, but for several decades. And my own familiarity with this is as old as 1991, when I was functioning as Director of Operation in NTPC. And Mr. Sharma had taken over as the Secretary of non-conventional energy. So in the beginning, what is MNRE today used to be a part of Power Ministry as a department. And then some years back, when I met Mr. Sharma, who used to be Joint Secretary in the Ministry of Power and later on Minister Secretary, when he became Secretary, he was the Secretary of what is today Ministry of New and Renewable Energy. And he told me that there is a concentrated solar power at the outskirts of Delhi, between Delhi-Gurgaon border. Gwal Pahari is the place, and that had been taken as a model, and this is not functioning. This was not functioning for years together. So can you make a visit? And that was the first time I heard about this. So before making visit, I did some literature survey of something that had been done on California and USA. So everywhere in the world at that time also this subject was very interesting, that you store the energy when solar radiation is available and use it when it is not available. Since then, I think a lot has happened in the field of new and renewable energy. Solar has occupied an important position. And in that context, what is the relevance of this? One has to evaluate, because now there are so many options. Solar power itself in the last 10 years, just 10 years, has come down from something like 15 rupees per kilowatt hour to now in the range of 2 rupees 30 paise to rupees 40 paise. So there are many other options which were irrelevant those days. Many other options of storing energy and converting it into power later on when solar power is not available. Those options were not available then. They were not available in 60s, 70s, 80s, 90s. And they were not available even till 2014-15, when the solar power in the new incarnation came to light, and India gave a boost. And at that time, some of the 30, 40 megawatt power station, the price was as high as 14 to 15 rupees per kilowatt hour. So it's a matter of last 10 years that the scenario about what should be the approach of technology and what should be the approach of planning in trying to store energy and use that energy or convert that energy into power at a time when solar power is not available. Many options. Now, in those options now, where does this concentrated solar power fits is a matter of evaluation. Even now, I have done some literature survey. Even now, there are questions about reliability of irradiation that causing a problem to them. Fortunately, what Malti presented today, I had not seen this table, that you have about a dozen power projects which are either under construction and a couple of them under operation. The two power projects which are under operation, one is Jaisalmer, I saw in the table, and it has an experience of maybe last 3-4 years. It would be good to find out what is the operational experience of this. This is the senior most now in the new incarnation, not very old, last few years. So what are the experiences and what are the feedback of this power station in terms of operational challenges and in terms of also cost? What is the cost of power that it delivers? And then we should need to evaluate, because so many options we are doing in the country. And as I said, that today battery has emerged as one, hydrogen has emerged as another. And just a few months back, very simple application that you just lift a weight. You lift a weight of sand or even steel blocks, and store that energy up, use that solar power, and keep that energy stored. And when you need power, you allow that to fall at a speed and rotate your rotor and generator, and you get power. So I think so many applications, and these applications have become relevant because solar power cost in India during daytime, you will see, and that situation is already emerging, that whatever capacity is built up, even at 100 gigawatt plus, we have solar power which is not being used during daytime. So some of the power projects which are large capacity power projects, they are asked not to produce full amount. So there is a waste. So therefore you will have a lot of power, solar power, and fortunately we have the three exchanges in India. You will see the cost of power during daytime, solar power, will be almost negligible. And many of you might have heard that in European countries, you are paid, not you are given the money. You are given incentive to produce power, not that somebody has to give you to just balance the grid. So that situation, you will have almost solar power almost free or at negligible price. And that solar power you will be able to use in technologies which can store energy and then produce power in the nights or in the evenings. So I think you have half a dozen options available today. And Indian companies are working on all of them, all of them. So it is in that context today we have a good number of experts who have worked on this field, and we would like to hear. And I would be particularly interested to know how is the operational experience of the Jaisalmer, which is the senior most in the series on the list that Malti just presented on the operational experience. My own thought is that perhaps it is still has issues. It still has issues, and anything has issues. Whether they are solvable, they are not solvable. Compare it with the storage that we will be able to do with, let us say, battery. Out of many, hydrogen is also that is coming up. Out of many options that are coming up for the evenings, that is the battery storage. Battery storage with a required capacity of megawatt hour for 2-3 hours to back up large solar power generation. And during daytime, you have the capacity in a manner that a good part of that capacity you are using for typical power applications, and a small part of it you are using to charge the battery. And then keep that energy and use it in the evenings. So like that, the options are coming up. So let us have a critical evaluation of whether, so far as government system is concerned, they are very positive. They're positive in the sense that every technology that is coming up, response is good. We have to see how our researchers, how our professionals, energy professionals are able to solve. I said that my familiarity in 1991 was that it was not workable. It did not work. Terry was very deeply involved in this, others were involved. But 91 story and today the situation is entirely different. And its relevance today has to be fixed in terms of how does it compete or how does it complement or how does it help in still pursuing with this. Does it, of course, battery has its own environmental ramifications. Pumped storage is coming up. Pumped storage will take some time, but 4 or 5 years' time, we will see something like 10,000 megawatt in a matter of 4 to 5 years coming up on the scene. Maybe later on, maybe 50,000 megawatt will come on the stream. So therefore, there again, you are using the cheap power during daytime and storing that power and producing this hydropower during nights. So that is another good system, and that is quite environmentally quite benign and favorable. So these are so now this particular technology was under sympathy those days. It was struggling on technological compulsions and technological challenges. Today, technological challenges of this technology, whether they have vanished, like some of the points that pros and cons just Malti was trying to put on the table. And in that, material is different, design has been changed, but at the same time, there are other difficulties still continuing. With all these put together, are there successful cases? Concept-wise, I don't think much has changed. Concept is same, that you are using this. But what has changed and what are the operational experiences of those design changes, operational changes, and more importantly, like it is a question today to all technology development, how does it become affordable? As I often say, the research is good, something you innovate. And anything that today is being talked in India and in the world in the field of renewable energy, there is nothing which was not talked 50 years ago. But 50 years ago, they were not accepted because they are not accepted in terms of economics. Same thing. We're talking everything we talked 50 years ago, again, we are talking the same thing. What has become affordable in terms of economics of its production, economics of its operations, manufacturing, whole range of things put together, that makes all the difference on research. And that is true for any research project. There are some research projects where, okay, we keep spending money, we still try to do some innovation or the other, but finally when it is accepted in the market is the point when it becomes an acceptable range of prices. So let us hear from the experts, and I would really look forward to listening about some of the successful cases. So with that, again, I welcome you on behalf of the India Energy Forum. And after discussions, I'll come back again toward the end. Thanks a lot. But this session that we organized is from the point of view of technology support. You see, administrative support, policy support is a different matter. This is a technology which I mentioned. Is
Yes, sir. Yes, sir.
which is almost 60-year-old. So technology, there is no problem that you are storing the energy in the form of, and then you are again delivering power. So this support of policy. Now, why is it that so many plants, 10 or 12 plants, which are already either in construction or in operation, why is it that it's not functioning? So you have to find first the perfect the technology. Somebody took care, somebody took steps. The first slide that was shown was about a dozen plants varying from 50 megawatt, 125 megawatt, 20 megawatt. Let us perfect that, because jumping on this, that give this, give that, then it won't work. Then it will be left behind. Somebody has brought battery to some shape. See, just 2 years back, it appeared hydrogen will be the substitute. In 2 years, battery is running ahead of hydrogen now. So therefore, this session, this vertical of India Energy Forum is not a vertical for that type of discussion. It vertical is, what is it where technology is an issue and what it is that is to be done. The concept is known. If material is an issue, if an operations of design issue is there, that is making it unaffordable. Volume, you see, in every research, why I feel sometimes quite concerned, and many of us feel concerned, that India does provide volume. Sometimes technology developers, they cry for volume. When I was trying to convert the CFL light to LED, the people, manufacturers were saying, give us volume. And we gave them volume. Through Bureau of Energy Efficiency and otherwise, by coordinating with different state governments, we said, okay, do it for 10 million or 20 million and bring down the price. The price was brought down. So India has that advantage which many other countries don't have, that you don't need to be sort of competing in export market. India provides the volume. So if 20 pieces or 100 pieces or 1,000 pieces, you are uneconomical. Are you economical at 1 lakh pieces? of 20 megawatt, 30 megawatt, 50 megawatt. See, today, the policy framework is such that this decentralized solar system in rural area, that needs a backup. And you can have as small as that. Now, 5 megawatt, 4 megawatt, 2 megawatt solar projects are coming, but they will have support, they will need support in the evenings. So it can be a range of this particular technology. But this session, if you want, we can have another session only on that. But this session is not just कि viability gap funding दे दो, ये करो, वो करो. Technology, 60-year-old technology, where are the missing links? And if somebody like SECI, a good organization to provide volume, they can coordinate on behalf of an, we have made that point, they can coordinate. But the question is that people, DISCOM will be asking. We also are trying to put pressure on DISCOM. The tariff should be low. So I think we should sit together. What are the missing gaps? Viability gap funding को एक मिनट बाद रखो, क्योंकि viability gap funding is by nature of this, that you are providing, one is that you are being provided cheap solar power. That is one, that is itself a viability gap funding. It was not available earlier there. So cheap solar power you are being provided, which is also the case in battery. And then you are being asked to sell at costly power in evenings. So true viability gap funding is by very nature. You see, emergence of solar has given rise to life to these people. Solar needs this backup, so the life has come to these people. So therefore, you have two types of inbuilt mechanism of providing viability gap funding. A cheaper power, cheaper solar, because during daytime when solar has crossed 100 megawatt, 100 gigawatt, as it is we are experiencing throughout the country to back down solar. So instead of backing down, I will use that solar energy for your need. So that is one viability gap funding. And then the evenings, if you see the exchange rates, they vary sometimes. So in the evenings, we give you higher rates. So that is another viability gap funding. So the issue is technology and sort out the technology. We will have another session on this subject because battery has its plus points, battery will have its minus points also. Pump storage also running in the race. And I tell you, within 4-5 years, we will have something like 10,000-15,000 megawatt of solar power. Solar power potential itself is very high. So this is pump storage. Potential is itself very high. So pump storage will also take over. So it has to compete with pump storage. It has to compete with battery. Pump storage does not have the type of problem which battery will have. A 10-year life, pump storage will have 50-year life. So each technology will compete with each other. I think those who ask for sympathy, solar asked for sympathy for 2-3 years. From 15 rupees, it came down 4 rupees, 3 rupees, 2.5. We are not giving value except for transmission. If I have to build, that is a different matter. So I think it is the technology people who have brought it to life. And if you are all the technology people, and as in what vertical Malti is coordinating in the Indian Energy Forum, it's not only an overall sort of policy level thing. This question is, this vertical is on technology. So I will again ask, and we will have more people. You all can suggest who all we bring, and let us study a little deeply into the working of those 10 or 12 which are under construction or under operation, where the shoe pinches. What are the problems that are there? And how can we, as I said, that two viability gaps funding are inbuilt in the process. You go on asking government viability gap funding. We are not giving viability gap funding in transmission. We have opened up transmission. So I think gone are those days where people have to ask for viability gap funding. Manufacturing, there will be something. Means I will put a higher import duty on others to compete with you. So therefore, that is again the viability gap funding. Somebody can buy at 10 rupees from China, and we will put 10 rupees more on tariff. So you have a viability gap funding. You can sell at 15, 16 rupees. So that type of policy things can be there. But not the policy give us money. We have given a lot of money to research people without much result. This is a challenge to research and technology development people. All right then, thank you.